So hello guys, welcome to my next vlog. Uh, in this video, I want to discuss one specific topic, that is GTD. That is one type of course we had. It is stands for Generation, Transmission, and Distribution. It means how the electricity produced and how it transmit and how it distribute and how we can get in our home also. That is the total things are comes under the GTD, that is generation, transmission, and distribution of electricity. In that, in last semester we had one a substation overview. In that we had a lovely uh, made one substation architecture. In that bus bars is there, current transform is there, and the potential transformers is there, and the main thing, that is the power transformers there. 5 megawatt the capacity of the power transformer. I had one internship at that places. I seen one transformer, power transformer, that is a capacity of 5 megawatt. In that transformer, I had saw two types of winding, that is primary and secondary, and it is a distribution type transformer. It means it have a the 330 33 kVA incomer and 11 kV outgoing. It means we saw the step down voltage. It means it is the distribution type of substation, and in that substation, we saw various types of bus bars and material used for the cable, that is mm, aluminum only. And in this substation, the common point, that is all types of substation are distribution type only. And in that distribution type substations, 33 kVA is the mandatory. I had two or three substation in my areas, that is in Kautemanka, district Sangli. And in that substation, all are the incomers are of 33 kVA, and outgoing outcomers are the 11 kVA. Some industrial areas and some owners was taking directly 11 kVA as their requirement, and we had 230 volt AC supply in our home, that is a single phase, and another one, that is a three phase supply 50 hertz on 450 cools on our agriculture sector. That is the basic thing, how the transmission it completed. We are generating electricity at the 11 kV, and we are using at the 450 kV. It means the long gap we can see in here, and up to the transmission line, up to the distribution point, it is a high voltage. But whenever we can see in the distribution transformer, at that place only the voltage can decrease uh, as long as possible. But in the transmission line, we can see the high voltages. Why means we have to limit the losses in the transmission line. That's why we need to increase the voltage of the transmission line while the transmit electricity from generating plant to distribution transformer. We can say throughout our home also. That is the overview of transmission of the electricity. We can uh, adjust those voltages, minimize and somewhat increase also. The 50 hertz frequency, it is not a perfectly 50. It roaming at 48.5 to 50.55.5. It is roaming always there, but we collectively we can call it is as a AC 50 hertz single phase or AC three phase. AC 50 hertz. Okay, that is about single phase and three phase. In three phase, we saw three wire system, that is R, Y, B. The R stands for red, Y stands for yellow, and B stands for blue. Are the three wires we can see in three-phase system, and the three-phase system in electrical, we can say department or background, we need to know the connections. In that connection, we have to know firstly star connection and delta connection. That is very important point. Once upon a time, whenever I gone there at my places of internship, the one specific question they're asking me regularly, repeatedly, why we are using delta to star configuration. What is the specific reason behind that? That is, I want to share with you uh, delta to star connection. In the delta, we can get three wire system, and we in the star we can get four wire system. Okay, three phases, and one is the neutral. And neutral point we can transmit up to the lower distributions substation also, and or we have option that is neutral point we can directly earthing, we can connect to the earth also. That is a major point we have to focus on that. If we want the neutral point, then we can transmit up to our home also. Okay, that is advantage of the star connection. Star and delta connection, that is the major difference in that. In that difference, uh, somewhat changes is also present there due to the increasing or decreasing order of the voltages. Some the reason is behind that why we are earthing those neutral point. In another video, I will tell you what is the reason behind that, why we need to earth those neutral point of the star connection. Okay, okay, I will tell. Somewhere in rainy season, what will happen due to the rain or due to the flash in transmission line, get the transmission line get energized automatically. Okay, and due to energize of the transmission line, the voltages increases automatically. Okay, due to increasing voltage automatically, the fault detention or fault energy transmission failure is somewhat possibilities are present there. That's why somewhat voltages are reduced or somewhat voltages are increasing. That's why we need to uh, earth one point, that is the neutral point we have to earth first. What will happen when we are earthing the neutral point? The increasing voltage or the decreasing voltage maintain will maintain whenever we are earthing the neutral point. Okay, that is the reason behind uh, earthing the neutral point. Okay, that is the things in happening in the substation. Day by day, we can collectively study those point and keywords also. Okay, that is the this is the day three of my starting the videos, and I just opened my camera and I just started. There is a no reason behind that. I just want to showcase myself and some other. That is not a part of education, and I have information, and I just opened my camera and I just started to speak. Okay, okay. Thank you so much. This is that is enough for today. Okay, next day onwards we can discuss technical topics. Okay. Thank you so much. Keep watching.